Hello, GCC, we're back. Now we're going to talk about solutions. So we have a lot of definitions to start out with and some terms for you to learn. A solution is a type of mixture. It is when we have a solute dissolved in a solvent. So salt water, for example, you dissolve salt in water, you have a solution. Coffee with cream, you put cream in your coffee, you have a solution. So a solute is dissolved in a solvent. It doesn't have to be two liquids. It can be a solid and liquid. It can be a gas and a liquid. It can be a gas and a solid. The states of matter do not matter. It's just a solution is a solute. You could have more than one, plus the solvent. So what's the difference between solute and solvent? Well, solute is what is present in the smaller amount, and solvent is what is present in the larger amount. And that's actually on the top of this slide. Here we go. Solute is the component present in smaller amount, so the one that there's less of. And the solvent is the one that there is more of. It's present in the larger amount. For example, 30% aqueous methanol solution. So methanol is a type of alcohol, but not one that we drink. Aqueous means water. So this is a water methanol solution. 30% is the methanol, 70% is the water. So which is the solute and the solvent? You are correct if you said methanol is the solute because it's only 30%, and water, there's more of it, 70%, is the solvent. Okay, what if we have a 70% aqueous, means water, methanol solution? That would mean 70% is methanol, 30% is water. Which is the solute? Which is the solvent? You're correct if you said methanol is the solvent this time because it's 70%, which is more. Water is less, 30%, so it's the solute. Okay, so now we know what solute in solvent means, and that's what a solution is. So solutions can be in any of the states, solid, liquid, or gas. Examples. We can have a gas in a liquid like our carbonated soda. We take the CO2 gas and put it into the liquid soda, so it's carbonated. We can have liquid-liquid mixtures or solutions like alcohol, rubbing alcohol, which is the alcohol and water together. We can have a solid in a liquid like salt water. Saline solution is salt water, right? We have gas and gas, air. We have a bunch of different gases, and the main gas in air is nitrogen, not oxygen, but nitrogen. So oxygen is a solute. Hydrogen, helium, carbon dioxide are all solutes in the solvent nitrogen. Nitrogen is the main gas in air. It's the main thing you breathe in and out is nitrogen. And finally, we can have solid-solid solutions like steel. Steel is made of iron with a little bit of carbon in there. It's mostly iron, but a little bit of carbon helps strengthen the iron into steel. So the physical state can be anything, solid, liquid, or gas in a solution. Now, like dissolves like. What does that mean? We're talking about polarity. So here we go. Polar and nonpolar, so important in this chapter. If you have similar polarities, you can form solutions and mix. So polar solutes dissolve in polar solvents because they're alike, polar and polar. Nonpolar solvents can dissolve in nonpolar solvents, nonpolar because they're alike. Nonpolar and polar do not mix. So we call this like dissolves like. Note, ionic compounds have ionic charges, right? But you need solubility rules to determine if they will form a solution with water. So solubility rules in your periodic table are for ionic compounds. We use like dissolves like when we're talking about covalent compounds, right? Polar and nonpolar covalent compounds. So if you want to know if things mix with water, you have to look at polarity for covalent compounds, but ionic compounds, you look at the solubility rules, which we already know. Great. So soluble and insoluble generally refer to having a solid in a liquid mixture. Like sodium chloride is soluble in water, but silver chloride is insoluble in water. Only 1 to 5% ionizes. Most of it stays bonded together as a solid for silver chloride. Now, miscible and immiscible may be new terms to you. Miscible and immiscible generally refer to liquid-liquid mixtures. Not always, but generally they do. And the word miscible means it mixes together no matter the proportion. For example, orange juice and water. You can have a little bit of orange juice and a lot of water and they will mix together. You can have a lot of orange juice and a little bit of water and they will mix together. Or you can have half and half orange juice and half water, and they'll still mix together. So when you can mix together, no matter your proportions, that's miscible. Immiscible means you do not mix. And in a liquid-liquid scenario, that would mean make layers. They make layers. Can you think of two liquids that make layers? Think of salad dressing, right? Vinegar and oil make layers. They are immiscible. Anyway, methanol is miscible in water. Okay, alcohols mix with water. But oil, we were just talking about oil, is immiscible in water, right? Water and oil would make a layer. They do not mix. So soluble and insoluble is solid and liquid combinations. Miscible and immiscible are liquid-liquid combinations. All right, so let's determine if these following are miscible, immiscible, soluble, or insoluble. Let's go down the liquid polar solvent column first. So we have a polar solvent. Will a polar liquid mix with that? And what word would we use? Polar liquid with a polar solvent, that's also a liquid. So we have a liquid-liquid combination. They're both polar. What word? You're correct if you said miscible. Good job. Okay, now we have a non-polar liquid in the liquid polar solvent. Non-polar and polar liquids. Immiscible. Good job. Okay, what about a polar solid with a liquid polar solvent? So polar and polar, but a solid and a liquid. Soluble. Good job. Now a non-polar solid in the liquid polar solvent. So we have a solid in a liquid, but non-polar polar combination. Insoluble. Good job. Now here's a tricky one. We have an ionic solid with a polar solvent like water, but we're talking about ionic solids now. Yeah, check your solubility rules for the ionic, right? Like dissolves like only refers to covalent. Now let's do liquid non-polar solvent. So a non-polar liquid is the solvent. Will a polar liquid mix with that? And what word would we use? So a liquid-liquid combination, but polar and non-polar. Yeah, that won't mix, but it's liquid-liquid, so we use the word immiscible. Non-polar liquid with a liquid non-polar solvent. So liquid-liquid, and they're both non-polar. Yeah, those will mix. Miscible. Good job. What about a polar solid with a liquid non-polar solvent? Solid in a liquid, but we have polar with non-polar. So that won't mix. And we would use the word insoluble because it's solid liquid combination. Non-polar solid with a liquid non-polar solvent. They're both non-polar, but we have a solid and a liquid. So we use the word soluble. Good job. Last one, we have an ionic solid in a non-polar solvent. So remember, ionic solids have pluses and minuses. This is non-polar. Would that mix? No, that would be insoluble. That would not mix. All right, very good job. We'll come back and try some more problems related to solutions. See you in the next video. Bye-bye.